No, we don't. Well, I told
Okay, guys, a little bit on the calendar here. We're doing things a little bit out of order. So we're going to cover 6.10 bearings, which is not going to be on the quiz on Wednesday. Okay, not on the quiz, but it will be a topic on the test. But I think we'll be able to get through it and start the quiz review. So the quiz is just everything that we did last week with the graphing, with the converting component form to magnitude direction and going back to component form. Okay, and then also angle between vectors. And then the quiz is on Wednesday, and then more problems. We'll spend a couple of days on that, and then test is next Wednesday. So if we can turn to page 21 in your packet. I put this on the side as a note, just to connect with something that that we know how to do. So standard position is where we move around the axis starting at 0. This is kind of like the right x-axis, and then we move counterclockwise, right? So if everything is in a quadrant, degrees and 90-degree increments, right? So 90, 180, 270, 360, moving in the counterclockwise. Now bearings, still the same coordinate plane, but bearing starts at north. So this is 0 degrees, and it's moving clockwise. So this is 0 degrees, this is 90, this is 180, this is 270, and then back to 360. Okay, so basically they're just 90 degrees off from each other. Right. I'll go back to the notes here in a second, but for instance, real quick, standard position, 120 degrees. We just go 90 plus 30, and that'll get us to 120. True bearings, if I'm trying to get to 120 degrees, then I'm going 90 and 30, but I'm going to end up in the fourth quadrant, right? And so the standard position for something that is 120 degrees true bearing will be 360 minus 30, which is 330. Right, so it's just, we're still using the same coordinate plane, but we're just counting from a different starting place, and we're moving in the opposite direction that we would expect. Okay, so bearing directions are angles given as rotations measured clockwise from north. So you're starting north and you're moving clockwise. Okay, so starting at 0, we go 90 plus 90 plus 30, and that gives us 220. So for instance, this example, 220, okay. All right, if this is 220 bearing, true bearing, then we know that 220, and also we're rearranging everything, right? This is now 0, this is 90, this is 180, this is 270. If you look at that quote unquote reference angle, what's this degree measure difference here? 50 degrees, right? And if you know this is 50 and you transfer this over to something that you recognize from a standard position, then this is 180 plus 50, which is really 230. So we're just gonna try to go through bearing, a bearing degree, and then from there, convert it to standard position, right? So if we can figure out what's the degree measure to the x-axis, then we can create another coordinate plane that is in standard position, and then we just count from that perspective. Okay, now there's a little bit of a shortcut to this, but I want to kind of show you this on the graph, and then we'll talk about the shortcut. Okay. So directions here: sketch the angle given in bearings, then determine the angle measure in standard position. Okay, so again, bearing of 160, that means I'm starting at the 90-degree measure that we normally consider 90 degree, but except we're calling it 0, and we're going in this direction. Okay, so 160, that means we're going to go 90 plus another what? Plus another 70, right? 90 plus another 70. And this is going to be 160 degrees. So he said 70, right? So I'm going to say 70 here. Okay. So we know that difference of degree measure from the x-axis. And now I'm just going to create something that we recognize so we don't get thrown off by all these numbers. So normally we associate this with 0 or 360. Right, 270, 90, 180. So this is something that we recognize. So if something is 70 degrees in the fourth quadrant off of the x-axis, what is that degree measure in standard position? Yeah, 290, right? 360 minus 70 is 290. So once you get it in position, then you can just translate that into standard position, right? Once you draw it out. Does that make sense? So bearing of 160, we draw our angle measure from the positive y-axis, and once you get to this, once you get to this degree measure, reference angle, then you can translate that to what does that mean from a standard position perspective. Okay, next up, 335. So that's going to be 90, 180, 270, 335. Thank you. Okay, so 335 minus 270. What's that reference angle here? 65. Okay, so I'll put 65 here. So that we don't get confused with all those numbers in front of us, let's just use something that, let's just put 65 here in place. We know this is off the 180 degree normally. So what is this degree measure in standard position? 180 minus 65 is 115. So we get enough information from a bearing perspective and convert it over to standard position. Yes. Yes, that's right. You could have started from 90, but I just always like to work with the x-axis since that's what we're always used to. But yes, you could start with 90. But I'm going to encourage us to always use the x-axis so that when it truly is a reference angle, that we don't get confused with the 90, because then the 90 degree is going to be a little bit off, right? So, but in this case, we could. Okay, next up, bearing of 212 degrees. Let's see, do you guys want to try this one? And then we'll see if this makes sense, and then answer any questions you have and practice a bit more. Okay, which quadrant is this going to end up being?
Third.
Third. $270 minus $212 is what? $58?
Yeah, 58.
58, okay. So once you get that reference angle, then that helps. Put 58 and 180, and that will help you get to that standard position measure, right? 180 plus 58.
Oh, I did it the opposite way. I did it like 32. Yeah, or what?
Oh, you went this direction?
Um. Yeah, but I did like 270 minus 32.
Minus 32.
See the 238.
Oh, right. So we don't want to, right now, you just want to figure out what that reference angle is. And then from there, from that reference angle, get to the standard position. So we don't want to play, you don't want to do that 270 and 238 because those are not lined up. So figure out your first goal is to figure out what this reference angle is. And then you're going to draw a separate graph and understand that it's 58 degrees off of the x-axis. So you do 180 plus 58.
No, I did. I just figured out the other side. Like I got 32 instead of 58, but they both add up to 90. So you get,
Oh, you got 32 over here.
yeah, that's
Okay. And then you did 270
minus 32.
minus 32. So you still got 238.
Yes,
Okay. That's fine. Again, I like the x-axis since that's consistent with reference angle, but if you get the right answer, that's perfectly fine. Okay, guys, you want to try number 4?
Yeah.
Which quadrant is this going to end up being? Third. So 270 minus 241. We know it's 29 degrees off of the x-axis. Does that make sense? Okay, so I wanted to show you from a graphical perspective so that you understand where bearings is and how it's connected or how it's different than standard position. But there's also a bit of a shortcut, so I want to talk about that. This formula is on your calendar page. The back of your calendar page, there's the point out this formula here. So bearing is starting at this 0 degree here, but really you can think of it as it's if you think of it as 360 plus another 90, which will give you 450. So a way to get to it without having to graph everything out is that your standard position is 450 minus true bearing. So that's always the connection between standard position and true bearing, is that if you do 450 minus whatever true bearing you get, it'll turn itself into standard position. So 1 through 4, let's just see if this formula works. I think it's great to know both ways of doing it. And that way, depending on whether you're trying to graph it or whether you're trying to just get to a degree measure, you can also use both just to confirm your understanding. Okay, so 450 minus the true bearing will get you to your standard position. So in our calculator, we can try that here. Our bearing is 160. I'm trying to get to my standard position. I do 450 minus 160, and that'll get me to 90. Bearing of 335. I want to get to standard position. $450 minus 335 gives us 150. Great, thank you. Bearing of 212. 450 minus 212 gets us 238. Bearing of 241. 450 minus 241. Okay, likewise, if I start with standard position, I'm trying to get to a bearing, I can also do the same formula. 450 minus standard position gives me the bearing. So that just stays right here. Same idea. True bearing measure is just 450 minus standard position. So the connection is that 450 is just 90 degrees plus 360 to ensure that you end up with a degree measure that's between 0 and 360, because it's 90 degrees off of standard position. Okay, any questions here? So we call they call this true bearing because it's starting from the north and counting clockwise. But sometimes there are these quadrant bearing where they tell you specifically where to start and which direction to move in. Okay, so let's go to page 22. Okay, directional bearing or quadrant bearing are angles given as a starting direction, either north or south, and then an acute angle of rotation measured towards the second direction, either east or west. So, so it says bearing of north 20 degrees east. So this one would be the same as true bearing because, if it's, they're always telling you where to start and which direction to move in. So north, and then I want to go 20 degrees to the east. Okay, 20 degrees to the east. So if I have this drawn in front of me, and if I'm trying to get to standard position, then I can just say, well, this is 90 degrees from a standard position standpoint. 90 minus 20 is 70. Okay, next up, bearing of south 41 degrees east. That means we're starting south, and then we're moving towards the east 41 degrees. So from a standard position standpoint, you can think, well, this is, normally I would just call this 270, right? 270 plus 41 will get me to 311. Okay, so let's try number 5. bearing of north. So that means we're starting north and we're going 60° to the west. So we're going to go 60° west. So normally we call this 90 degrees, right? Plus 60. What will that end up being? %. So I feel like this is pretty straightforward because they're telling you where to start and they're telling you which direction to move, and they're asking you to move that many degrees in which direction. Bearing of south going 35 degrees east. So we associate what degree measure here?
Oh, 270.
270, yep. So 270, we have to go into the fourth quadrant, so I got to add 35. Now, this is the time when we would kind of break the rules with reference angles, because this is not really reference angles. Then we're just kind of following whichever direction they're leading us. So in this case, we are going to use 90 and 270 to help us move around, right? So 270 plus 35. Okay, try 7 and 8, see if this makes sense to you. So we start north and we go 72 degrees east. What's our standard position? Degree measure. 18, 90 minus 72.
70 or 18360.
Right, so we want to go in the direction that they're telling us. So if I'm going east, I got to go right. If I go right, I'm going to end up in the first quadrant. The only way I'm going to get a first quadrant degree measure if I do 90 minus 72. All right, so depending on whichever quadrant you know you're going to be in, just make sure whatever answer you get lies in the quadrant that you want it to be in. So number 8, we start south, we go west. We're going to land in the third quadrant. So 270, 270, what? Minus 11, right? Because we know where we're going to end up. So if we accidentally make a mistake, if we do 270 plus 11, we'll realize, wait a second, that's not third quadrant. So you would do 270 minus 11. Right. Well, because of bearing of south, that means we're starting south and we're moving 11 degrees west. I know we're kind of breaking the rules with 180 degree, because with bearing, we're never starting on the x-axis, we're starting on the y-axis. So that's why we're doing 90 and 270. Yeah, that's right. That's right. Yeah, so any bearing problem, you're always starting north or south. So if it's directional bearing, you're either going to be adding and subtracting from 90 or adding and subtracting from 270. All right, kind of breaks the rules a little bit with when we talk about reference angle, we say never to use the y-axis. But in this case, because the bearing is starting on the y-axis, we're kind of forced to use it. On the test, but not on the quiz. Okay, hopefully you guys find this pretty straightforward. Okay. So let's just start our quiz review. If we finish this, then I have another quiz review for us to do tomorrow. So if you guys can turn to page 19. And we'll just go through this as much as we can together, and then so page 19. So these are the reference vectors. This is vector A, this is vector B. We want to create a situation where we have vector B minus vector A. And because we're so used to component form, I'm just going to go ahead and create component forms for both these vectors, and it just, I find it more straightforward. So vector A, we always do horizontal and vertical, right? So this is 2 to the, yeah, 2 to the right and 3 up. So we know that's both positives. Okay, what about vector B in component form? Negative 5, 2. So I'm going to draw vector B. And then vector A, instead of going up and to the right, it's going to go down and to the left. So I'll draw vector B. I'll start here on the right side, because I know I'm going to end up somewhere over here. Okay, so just pick a point. So I'm going to start off with vector B, because that's what they want us to do, vector B. So I'll go left 5 up 2. Negative A. So instead of right 2 up 3, I'm going to do what? Left 2 down 3. Yeah, so I always like component form. It just feels we're so, you know, eventually we're going to be using it so much. It's just also nice to see that connection with drawing everything out. So left 2 down 3. And you're going to pick up where you left off. So B left you here. And then so from here, you're going to count negative A. So left 2 down 3. So your resultant vector just starts at the very beginning and ends where you ended up at the very end. So this is vector B minus A. So let's find the component form for this resultant vector. Left, how many units? Left 7. And then down 1. You don't have to do this, but you know, this should match with what we do algebraically, right? So if I do vector B minus A, I should get the same thing as this, right? Except this feels more cumbersome because we got to graph it, but you got to at least do, there'll be a few where you have to graph, but it's nice to be able to confirm your answer out in component form. So I'm just gonna show that work there. You don't have to on the quiz, but I just want to show you that everything should line up. So negative 5 minus 2 is negative 7. 2 minus 3 is -1, so it lines up either way, algebraically or graphically.
So like for resultant vector, would you want it to be like dotted lines like that? Like,
You don't have to, no, you just label it, just label it. I just wanted to show a different color to see the distinction, but yeah, you can do however way you want to show me, just label it. It says find the component form, okay, which we did, and the magnitude of each resultant. So magnitude is just Pythagorean theorem, right? So square root of a squared plus b squared, root 50, or if you want to reduce it, you can, but I'll accept either form.
You get the magnitude again?
Magnitude is square root of a squared plus b squared. Imagine finding the hypotenuse of a right triangle. And I like to always leave the negative out of it because I know that a squared b squared is going to always get me positive numbers. So I just do 7 squared plus 1 squared. Yes.
Right, in my group, with that, would you have it for itself? You want it to be.
Uh, for notation, I want to see some notation involving that.
Not the notation, the group that, like, if I.
Yeah. You don't have to simplify it. Either way is fine. Okay, you guys want to try number 2 and I'll work alongside you guys. So it's nice having component form, right? You can just use those numbers to figure out where to move. Sorry, I started a little too high here. Let me try again and run out of space. Any questions? We'll skip the 3 and 4. We're not going to do this for the quiz. I want to do one of each type if we can. But any questions here with 1 or 2? We're good with wrapping it. Okay. So I want to try number 5, and then we'll do 8, we'll do 9, we'll do 13. But I just want to do one of each type. So tomorrow for classwork, you guys can have something to work off of and continue with the practice. Okay, so number 5. Use each set of points to create a vector with initial point and terminal point in alphabetical order. So in this case, we're going to start at A and go to B, start at C and go to D, start at S and go to T. So for each, find the component form, write as a sum of unit vectors, and find magnitude and direction. So remember, if we wanted to get from order pair to vector form or component form, it's this formula, right? X2 minus X1, Y2 minus Y1. Okay, right now we'll just do number 5. But the nice thing about component form is that it's easy to get from here to everything else we're looking for. Unit vectors, we just write it as I and J. Magnitude, Pythagorean theorem, direction, inverse tangent, and then adjust depending on which quadrant you want to be in, either add or subtract from 360. Or 180 or 360. So first, how do I write this in unit vector form? 8I minus 6J, yeah. So component form, sum of unit vectors, magnitude. Use the vertical bars to indicate that. Pythagorean theorem. Okay, direction, inverse tangent, B over A. Let's focus on the quadrant that this is in. If I go 8 to the right, down 6, which quadrant am I in? Quadrant 4. So how do I make that adjustment with that reference angle? 360, yeah.
Add the unit vectors for ourselves so I can remember.
Sorry?
Why don't you just add the unit vectors?
We did. It's 8I plus negative 3J, 8I plus negative 6J. I just put a minus there. All right, we'll save 6 and 7 for tomorrow for practice. Yes.
I think it's in the fourth quadrant again.
Right. So follow your component form. So I'm going 8 to the right and 6 down, right? Fourth quadrant. Yeah. So you can always imagine where that component form is taking you, and then from there you can decide how you want to play with that reference angle. Okay, let's do one more and we'll stop. Okay. If
we could just try 8A and B, and then we'll pick up the rest tomorrow. Thank you.
So I'm just adding and subtracting the vectors and multiplying by any coefficient that's necessary. So vector u, changing the signs, I have -5, +12. 1/3 w, I'm gonna take w and divide it by 3, so 3, 1, put a minus in between. And now I'm just gonna subtract or add by resulting vectors. -5 minus 3 is -8. 12 minus 1 is 11. And take vector v and double that. So it's in vector v is in unit vector. So I just want to rewrite it as 1, -2. Multiply that by 2. I get 2, -4. So there's 2v in vector form. There's my u unchanged. I put a minus in between it. So 2 minus 5 is -3. -4 minus -12 is 8. -4 plus 12 is 8. Tomorrow we'll review orthogonal vectors. We'll review finding the angle between vectors. All right, go over and get your phones. Yeah.
That's not going anywhere. I'm like, I'm practicing. I can't. How did you use it?